خلي يبدا تو يبدا 25.
Okay. Hello everybody. So we start our new session and we will start with we'll start the first communication will be presented by Dr. Miftah Ahmed Diab. He is from Libyan Petroleum Institute. Currently he's in the Exploration Department Petroleum Geochemistry section. He obtained his PhD in 2015 from Newcastle University, and he published a lot. The last paper was about the hydrocarbon source potential of the Paleozoic rocks of the Gdamis Basin in northwestern Libya. And today he will present for us a talk about the source rock characterization of the Awinat-Awinin formation, Gdamis Basin, western Libya. You have the floor. Yes.
Peace on. Okay. Good afternoon, ladies and gentlemen. My talk today about the source rock characterization of the Awinat-Awinin formation, northwest Libya. We'll start with outline presentations. We start with objective introductions and study area structures. Okay. With presentation outline is objectives, introduction, study area, which means structure, framework, stratigraphic, and results and conclusions. The main objectives of this study to investigate Awinat-Awinin as is a source rock as well as reservoir based on their organic enrichment and hydrocarbon potential, thermal maturity, and deposition environment. The location of the Gdamis Basin is located on the western part of Libya and eastern part of the Algeria and south part of the Tunisian. The border of the basin is Girgaf Arch from the south, Hohengraber from the east, and Tibesti Arch from the north, and decided from the Algerian border to the formations. What? Okay, later on I will show you the study area. This is the location concession that I selected the wells from it. I select 3 wells from that one to do geochemical analysis on it to investigate Awinat-Awinin as the source rock in the study area. So before we're talking about the geochemical, we start with talk about the structures, events happened in the area, particularly on the Libyan part. So we have several events, meaning conventional and extensional events. The Pan-African orogeny structures that formed during late Precambrian to late Carboniferous tectonics. This Pan-African created vertical northeast trending basement-related fault counterbalanced by conjuncted northeast, southwest, and northwest, southeast faults. Then, starting from Caledonian comparisons, second event began during late to early Silurian, which reactivating the reverse movement of the older northeast fault and resulting in the erosion along northeast trend arch. This movement may have caused the Girgaf Arch, meaning Girgaf High, Timbuktu Arch, Mizidri High, Nufusa Uplift, and Tatwanian Arch. This Hercynian, later on, happened Hercynian structure trend, which is caused by the late Carboniferous collision between Gondwana and Laurasia. The last one of the youngest one, the Albion event, occurred in Miocene time, is made of the 3 comparison episode, used the major stress direction oriented approximately north-south. This event were consequence of the convergence and collision of the European and African plates. This phase used by block tilting in the Gdamis Basin. All these events, movement, play a role in the formation accumulation of hydrocarbons and in the Gdamis basins. We start with stratigraphic sections of the Gdamis basin, as using Paleozoic, start basement, then Hassauna formation, Hawaz, Milias Shugran, Muminiat, and Tanzift, Akakis, then Tadrat, Onkaza, and the main concentrated on the our study mainly concentrated on the Havana formations as source rock, here Upper Devonian source rock. The main component or lithology unit is shale and siltstone as well, but the local on the base of the unit is the limestones. We start from the geochemical analysis. The first well log is represented the concession NC118. We see the different parameters here, TOC, different parameter used using TOC, free hydrocarbons, potential hydrocarbon, carbon dioxide present, hydrogen index, oxygen index, production index at Tmax. So we have the 3 units, and based on the geochemical data, meaning 2C and Rocky-Val data, we subdivided the ammonatonin into 2 parts, upper part and lower part. The upper part represented the ammonatonin C, the lower part represented the ammonatonin A and B. So from this log, you see the upper part of ammonatonin, you have rich TOC, and let's say a little bit saturated by hydrocarbons, and the potentiality rich more than 20, and the carbon dioxide is there. Hydrogen index reflect the quality of kerosene, and the oxygen index represent the low oxygen that time, so that organic matter preserved on the maybe suboxic to anoxic environment. Production index, you see, less than 0.2, so still early mature to slight middle mature. Tmax also clarify this one. But when you see the lower part, presenting ammonatonin A and B, so the TOC is very low, saturated hydrocarbons very low as well. Potentiality, there is no potentiality on it. And the hydrogen index, little bit, it's okay, but it's not, maybe it's that organic matter is weathered that during the depositions. So the next one, representing concession 143. So you see that you see here, as I told you, that the ammonatonin information subdivided in 2 parts, upper and lower. So the upper part represented the main source rock on the concessions. You see the lower part is, most of the reading is low, so it's not source rock. The third part is concessions in C5, meaning this was selected in C5. So here you see the upper unit and lower unit as a source rock. So you see TOC is high, potentiality is high as well, and the quality of hydrogen, meaning the hydrogen index, it's okay as well, and oxygen index is low, and the production index is high, and Tmax is reached the middle mature stage for hydrocarbon generations. So we do some geochemical relationship between the TOC and hydrocarbon potential, meaning S2. So the ammonatonin C formation you see here for 3 parts of wells. So you see the best one is Z5 and C5, meaning fair to slightly good. In the ammonatonin A, B, and A formations, you see the well Z5 and C5 is very good to very good as source rock. Here you see the production index to pyrolysis temperature Tmax. We see most of the samples plotted in the hydrocarbon generation zone. Some samples is non-hydrocarbons and some samples is low maturity. For the quality of oil, so we do the same TOC with hydrocarbon potentials. You see some samples, most of the samples from ammonatonin B and A is non-source rock, except for the concessions in C5, but the others is ammonatonin C presented oil prone and highly oil prone in these areas. We do some other geochemical relationship. We have the oxygen index with hydrogen index for both ammonatonin A and B. So this is ammonatonin C formations. So most of the kerosene here is type 2 kerosene. And the maturity of this one is early mature to slightly middle mature for hydrocarbon generations. This is for ammonatonin P and A. So most of the samples is plotted on the type 3 kerosene, and some of them is in type 2 kerosene, and low maturity on this. So when we talk about the oil and gas produce or looking for deposition environment for the source rock. So most of the awanatunin C plugged in the mixed oil gas prone source rock to gas prone, but the other awanatunin P and A, the best one is at Z5 and C5 is mixed oil prone with gas prone based on the kerosene type. So the kerosene type is mixed between type 2 and type 3. This microscopy photos showing us the type of organic matter. So in the right one, you see the amorphous under transmitted light and under fluorescent light. So we did the transmitted light and the fluorescent light. Transmitted light show the component itself. It's amorphous or polymorphous, but the lower one is fluorescent light, which shows the preservation of organic matter. It's well preserved. You see the color of that color is orange to slightly orange, is indicate us that organic matter is well preserved and deposited in marine environment. The same here, we see some polymorphous for the awanatunin and some polymorphous. So we reach the conclusion. The awanatunin information consists of dark gray to black shells, the stone with the sand and stone articulation, local limestone, which is from the Upper Devonian, field and Flaminians. Based on geochemical screen, the awanatunin information in the central and west central part is subdivided into units, upper and lower. The upper unit represented the awanatunin C members, resilient to Flaminians, and the lower unit is represented the awanatunin P and A member, filial to the Fenians. The upper unit has a thick range of 75 to 100 meters, consists of a good source rock with type 2 kerosene dominated by amorphous, polymorphous, meaning spore, color, and some zeoclasts such as chitinozoa organic matter with high potential for generating significant amount of oil or amount of hydrocarbons. The lower unit B has thickness between 200 and 350. They are considered to be source generated gas to oil prone. It's alternated between type 2 and type 3 kerosene, amorphous, polymorphous, and phytoclastes, organic matter in the central part of the basin at concession in C5, whereas the western part of the basin, this unit represented as reservoirs. The organic phase analysis indicate that the level of thermal maturity of awanatunin information is graded from 4.5 to 5.5, which is suggesting early mature to slightly middle mature for hydrocarbon generation. According to the paleofacies and GC data, I have not shown any GC data because of bad quality, so I'm sorry about that. The awanatunin information appear to have been deposited into oxic to slightly anoxic alluvial take to marine environment in the greater part of the Damas Basin. Thank you.
Thank you. So we have 5 minutes for discussion. We have some time for that. Any questions, please?
Yes.
Yes.
Anis from ETAP. Thank you for your best presentation. Question for, in this area you have produced oil, have correlate with the awanatunin formation or?
We don't do any source to oil correlations for the awanatunin, but in the Nigerian part, the awanatunin is a producer, hydrocarbon, so the source rock. Later on I think in the Morocco, in 2010, they do the conference or the workshop about the Paleozoic and recognize the awanatunin as a hot shale and hydrocarbon generated. So we need to do more advanced geochemical analysis such as GCMS, such as isotopes, and make correlation between oils itself and oil to source correlation. So later on, inshallah.
Okay, thank you. Any more question? If not, we accumulated some delay, and we will go directly to the next presentation to win some time. So, the next.
Thank you.
Thank you, Mohammed. So we move now to the next presentation, which. So, hurry up. So the next presentation will be given by Walid bin Ali. He's from the University of Science, University of Tunis, Faculty of Science. He's currently preparing a PhD in the Upper Jurassic Lower Cretaceous deposit on central and southern Tunisia. So the paper is entitled Upper Jurassic Lower Cretaceous Deep Marine to Fluvio-deltaic Transgressive Regressive Events as inferred from surface and subsurface data in Atlas, Tunisia. Too long title.
Okay, thanks.
For the presented work, we'll adopt the following plan. We're starting by introducing the objective and the problematic, then the geologic setting, the lithofacies analysis and depositional environment, early Cretaceous and conformity and regional eustatic curve, new regional correlation schema and chronostratigraphic correlation, the implication on hydrocarbon, and we will finish by conclusion. Well, the Upper Jurassic to Lower Cretaceous succession on the southern part of Titian Ocean has been considered as challenging both in stratigraphic, has been considered as a challenging target for stratigraphic interpretation and petroleum exploration. These strata are well exposed in central Tunisia, which allows to study the analog reservoir that produced well in Libya Basin and in numerous Cretaceous basin in Titian domain. Well, within this basin, the sedimentology are controlled and affected by tectonic, salt, siliciclastic input, and a high frequency eustatic sea level fluctuation. So, for this, we will adopt in this work an integrated approach used and combined surface and subsurface data with high resolution sequence stratigraphy, dynamic sedimentology, previous biostratigraphic data, and we will propose the history and the events that has been occurred during this time interval. So the objective is to description of marine sedimentary events using a process-based dynamic stratigraphy concept, understanding the facies succession and genetic architecture of sequence stratigraphy in platform to basin sediment, and understanding the eustatic and tectonic control on conformity and help determine the factor influencing sedimentary facies and dispersal pattern. And a new facies pattern and the chronostratigraphic based model will be presented. So, occurs on the eastern part. The study area occurs on the eastern part of the central and southern Atlas of Tunisia and extend from the north short range in the south to the north, so-called north-south axis. The studied area will be subdivided by the east-west trending fault of Buhidma into two parts, the Meknesi Basin to the north and the Buhidma Zimlet al-Bayda to the south. The study time interval includes the Newcomian first regressive sequence of Sidi Khalif, Malusi, and Boudinar. As we said, it consists of a complex stacking pattern and are formed essentially by siliciclastic fascies bounded by a transgressive carbonate layer. For this reason, we will simplify and use a synthetic composite log that represents Sidi Khalif, Malusi, and Boudinar. As we shown, it is formed by a stacking of bounded and conformity sequence. The complete sequence are commonly starting with conglomerate that's shown in Jbal Ruiz, ammonite, and belemnite. The next unit are formed by interbedded shale and sandstone, and based essentially on sedimentary structure. This unit can be subdivided into three subunits. The lower part shown a shale interbedded thin-bedded sandstone exhibiting amalgamated HCS and planar lamination that evaluated into 2-3 meter wavy planar lamination. It consists of well-sorted sandstone. Within the lower and middle part of this succession, it reflects a high energy environment and can be attributed to upper shore face to foreshore setting. Within the third subunit, the shallowing upward character is more attested, and it is formed by low-angle cross-stratified sandstone exhibiting at the top flazer-bedded sandstone. The transgressive sediment of each sequence is represented by condensed fossiliferous and butyrated carbonate that exhibiting ammonite, belemnate, brachiopods, and can be attributed to deep marine shelf. The sedimentation grading upward into shale admitting thin-bedded sandstone. The lower part of this unit is containing HCS structure and evaluate into symmetrical ripple marks that containing ophumorpha burrow. This burrow reflecting relatively shallow, well-oxygenated water. So this offshore, this unit reflecting an offshore transitional zone passing upward into wave-dominated storm-influenced shore phase. This is for the Sidi Khalif formation. For the Malusi formation, it is subdivided into lower and upper Malusi formation. For the lower Malusi formation, as being shown in satellite image, it is formed by well-channelized sharp-based sandstone that contains cross-bedded sandstone, ripple marks, herringbone, and locally gravels and coal. In more south position in Urbata locality, this unit shown a well-presented tidal bundle that reflect neap spring fascies and can be clearly attributed to tidal channel fascies that cuts into the Sidi Khalif formation. The upper Malusi is formed by alternating dolomite, shale, and sandstone. Dolomite, the Oolitic dolomite shown started generally by lag deposit. The sandstone are rich in ripple marks and shown herringbone cross-stratified. So this unit can be attributed to show lagoon fascias. And the succession evaluate into the classical coarse granite through gross sandstone with wood fragment, the typical facies of Boudinar, fluvial Boudinar facies. So the constitution of the vertical evolution of fascies provides us to propose a fascious model that shows the fascious repartition, repartition. This part of study allows us to attribute the succession, the Newcomian succession in McNessy Basin to wave-dominated and storm-influenced shoreline that evaluate with the lower Malusi formation to tidal and wave-dominated shoreline. So now we will develop the succession of McNessy Basin margin, and we took the section of Bohedma. It consists a key factor to understand sedimentary event and tectonic event of the Newcomian age. This section shows clearly the transition between the Nara, the Upper Jurassic Nara formation, and the underlying Sidi Khalif formation. So within this unit, no datable fauna was recorded. But laterally in Al Karma section, rare preserved ammonite imprint have been recently discovered and has been attributed to the lower Titonian in age. So it is the same age, this unit presents the same time both in Jbal Ruiz and Jbal Bohedma. So the succession grades upward into grading upward into massive sandstone. This massive sandstone exhibiting a flame structure and evaluate into ripple into shale clast, and these shale clast rip up shale clast are interpreted as a result of the cannibalization of the backshore during period of shoreline retreat driven by the sea level rise. Comparatively to the Malusi section, the Malusi sandstone, to the Sidi Khalif sandstone of the McNessy Basin, this sandstone is a rare example of well-preserved forced regressive sandstone. So the falling stage deposits are partially preserved here. In such case, only the top of these massive sandstone deposits were worked by a transgressive wave ravinement surface. It's very important in studying, in reservoir studying, because the transgressive sandstone are associated with some giant petroleum system like in Brent system. So the next unit consists of nodular and slumped carbonate beds that contain a mixed ammonite fauna. Mixed ammonite fauna of Kimmeridgian, Lower Teutonian, and Upper Teutonian. We will evocate this unit later in correlation. So this carbonate beds can be attributed to microcantium zone of the early Upper Teutonian age. This unit is capped by conglomeratic layer and are separated by the classical oolitic fascies of the Upper Malusi by a thick shale admitting thin-bedded sandstone and some gypsum layer. This thick shale contains ripple marked sandstone and plant fragment. Such character reflects an interchannel to pond environment. So the next step of our work is to define the discontinuity within the late Jurassic early Cretaceous age. So there's unconformity was correlated by ammonite fauna and was tied to the time scale of Granstein. Regional sea level curve was proposed. The overall trend of the sea level curve constructed based on the transgressive regressive sequence of central Tunisia and the global curve is quite similar. So this defined unconformity will be useful in interregional correlation. So we remark that in Buhidma section, the first massive sandstone are correlated with dolomitic sandstone recorded in Jebel Lerwi section. So this event represents the first siliciclastic input that reached the Meknesi basin. That we said the nodular carbonate, the nodular carbonate recorded are attributed to microcontium zone. So in Jebel Buhidma section, record a time gap that extend from the microcontium zone to the lower Valanginian in age. And the southern Tunisia, the Meknesi basin are related in the southern Tunisia by incised valley cut and fill. So this time gap can be explained by a tectonic event, a major tectonic event. It corresponds to a new Cimmerian event that has been well documented in northern Africa, in Sinai and northern Egypt, and even in Saharan domain. The new Cimmerian generated thrust uplifted area was exposed to extensive erosion, and siliciclastic and carbonate sediment were shed into the central Tunisia Neocomian platform. We shown that during the late Teutoonian age, the sedimentary package in Jebel Buhidma was similar to those recorded in Meknesi basin. And the reworked Kimmeridgian fasces after the New Cimmerian event
Just a second, Walid, just a second. The next presentation has been cancelled, so we'll let Walid finish his presentation, okay?
So, as we said, the southern Tunisia, since the New Cimmerian event, new tectonic age, since the New Cimmerian event, during the upper Teutonian age, the southern Tunisia and uplifted Buhidma Zimlet al-Bida area were an eroded zone, and the reworked sediment were led to the central Tunisia. So the evolution of fascists in the central Tunisia and in Meknesi basin were affected by this tectonic event. We show for the tidal fascists and associated tidal channel in central Tunisia and southern Tunisia were coincide with early transgressive age and are related in southern Tunisia by siliciclastic sediment and estuarine fascias. And we remark here that the southern Tunisia are capped by numerous time gap. So our work provides to study the events, the sedimentary and tectonic events, and allows to propose a new chronostratigraphic chart for the Newcomian age in central and southern Tunisia. The proposal for the depositional model, the proposed model allows an interregional correlation of the main sound lenses architecture and providing a new regional correlation schema which may be constitute a very useful petroleum prospection. So, for the application on hydrocarbon exploration, المكناسي basin, the late Jurassic, lower Cretaceous succession in Melusi section may be interpreted as wave-dominated, which forms some important reservoir worldwide like the Niger Delta and the Brent Delta. In landward setting, incised valley depositional system are important because their regional surface are assumed to have chronostratigraphic significance and sequence-bounded unconformity, and the associated overlying field have economic significance in hosting oil and gas reservoir. So, the sequence stratigraphic interpretation and chronostratigraphic framework were used to establish the depositional history of basin margin and related landward area. The southern part of Buhidma fault area is dominated by incised valley cut and fill associated with forced regressive event, which correspond to McNasey basin deltaic surface and carbonate deposit time equivalent. Incised valley form under two distinct phases, one dominated by fluvial process during valley incision and one influenced by fluvial estuarine and marine process during subsequent infiling of the valley. This study provides a subdivision of the Teutonia Valanginian succession into 7 third-order sedimentary sequence bounded by 6 diachronous discontinuity, and gives better define to different depositional environment in the study area. The transgressive sandstone body within the Sidi Khalif and Melusi formation suggests deltaic and wave to tidal dominated shoreline sediment dispersal pattern that appears reworked. Thanks for your attention.
Thank you, Ali. Okay, any question? No.
قبل كل شيء I'd like to thank you about this presentation. كانت جيدة. عجبتني الثقة بالنفس اللي عندك بالرغم من الخلل اللي صاير في بداية البرزنتيشن، لكن you manage to control and to go on. فهذه very positive point. اوكي هذه for you. لكن ما يمنعنيش ان نعلق لك على بعض الفيجرز كنت حاط عليهم الكتيبة، فكانت very dark. كناش نقدروا بالرغم ان هي مشكلة حلها بسيط جدا. هذا كله نسمعش فيها. I can shout.
Hello.
تسمع هو؟ Is it okay؟ نشكرك قبل مش نرفع لك المعنويات. البرزنتيشن كانت جيدة بالرغم من العقوبات الأولى اللي ما طلعتش بعض الخرائط. It's very good. لكن هذا ما يمنعش ان نقول لك رد بالك من بعض السامبل ميستيكس. يعني كان بعض الصور كان عليها كابتشر أو كاتب عليها، كان ما فيش هذاك البيج كونتراست بين الصور وبين الخلفية، فإتس hard to read the writing. فهذا try to. حاجة ثانية بنقول لك عليها إن any photograph you take in the field in the lab anywhere you have to put a scale باش يعرف حجم العمل اللي انت درته. مرات الاوتكر بيكون صغير لكن انت الباين مشتغل عليه لارج سكيل، فيفضل حتى اي زميل ليك ولا اوقف تحته وصور. It will show the work. Thank you.
Okay. Yeah, he will be more relaxed next time. But the presentation was well structured, I think. And also the new approach. Also, this is, I think, it's a new approach in the area, to address the area.
Just to stimulate his reflection, you said that in Jbal Bouhedma, the Sidi Khalif, the age of the base of Sidi Khalif is the same, has the same age of the Sidi Khalif formation in Jbal Ruiz. So how much kilometers between Jbal Bouhedma and Jbal Ruiz? 100? 70? But you know the concept. We continue to work with the concept of the diachronism. Professor Mrabit indicated that the age of the Sidi Khalif formation is diachronous. So you are saying that it's not the case. It's the same age. So
The reflection is that this deposit is transgressive. Yes. Transgressive. How to explain this transgressive started in Bouhedma outcrops. The transgressive is from the north, not from the south. Yeah. And the model of diachronism, the famous model of diachronism, is supported by a fact that the transgression, the lower part of Sidi Khalif formation has been produced in has been dated upper Titonian in Jbal Bouhedma and Middle Baresian in Jbal Malusi.
So the next, thank you. Thank you, Walid. You had it. Who is? No. So, the next speaker is here or not? Please, Hassan Afouri, Adrigan, Jeremy Jacob. They are here or they are absent? They are absent. So, if it is the case, the session is over. So the session is over because we have 2 absences. So, yeah, for the ETAP team about the Austrian phase and also this presentation about the Absent Bayesian structural framework. So thank you for your presence, attending, and you can go directly to the coffee break. No? Better luck for the next time, okay? Thank you very much.
I'm so tight, you let me know everything's alright. I'm hooked on a feeling, I'm high on believing that you're in love with me. Lips as sweet as candy, its taste is on my mind. Girl, you got me thirsty for another cup of wine. Got a bug from you, girl, but I don't need no cure. I just stay a victim if I can for sure. All the good love when we're all alone. Keep it up, girl. Yeah, you turn me on. I'm hooked on a feeling, I'm high on believing that you're in love with me. All the good love.
I've lost the use of my heart, but I'm still alive. Still looking for the light, the endless pool on the other side. It's a wild, wild west. I'm doing my best. I'm at the borderline of my fate. I'm in the hinterland of my devotion. I'm in the front line of this battle of mine, but I'm still alive. I'm a soldier of love, every day and night. I'm a soldier of love, all the days of my life. I've been torn up inside, I've been left behind. So I ride, I've the will to survive.
Alto Centro voy para Macané, llego a Puerto voy para Mayarí. De Alto Centro voy para Macané, llego a Puerto voy para Mayarí. De Alto Centro voy para Macané, llego a Puerto voy para Mayarí. El cariño que te tengo no te lo puedo negar. Se me sale la babita, yo no lo puedo evitar. Cuando Juanica y Chan Chan en el mar señan arena, como se cundía el jibe, a Chan Chan le daba pena. Limpia el camino de paja que yo no quiero sentar en aquel tronco que veo y así no puedo llegar. De Alto Centro voy para Macané, llego a Puerto voy para Mayarí. De Alto Centro voy para Macané, llego a Puerto voy para Mayarí. De Alto Centro voy para Macané, llego a Puerto voy para Mayarí.
لطفي.
Good evening. Just first of all, please, I would like to ask the speakers to sit in the first row, just to know who's present, who's no. Okay, so let's resume the last session of today. And I count on the speakers to keep everyone awake for this last session. And the first presentation will be done by Mr. Faris Khmiri, and it's entitled Footwall Traps in Fault-Related Faults and Thrusts, Potential Structure for Exploration in Tunisia. So Mr. Faris Khmiri holds a master's degree in geology since 2005 from Tunis University, and he joined ETAP in 2007, and currently he's in charge of Region 1 within the Exploration Study Department. So Mr. Faris, the floor is yours.
Thank you. I would like to thank assistants present today here to show them some of about potentiality of Tunisia, some of less developed potential traps are footwall traps in fault-related faults and thrusts, potential structure for exploration in Tunisia. Donc for the outline, I will start by an introduction. I give some world examples of footwall traps and oil fields, and some Tunisian examples. Khsham al-Artsouma structure from central Tunisia, and Ktifa structure in Qirwan Basin, and some reflection about the northern Tunisian thrust belt system. And I conclude my conclusion. So here's the orogenic belt worldwide, and as you see, a lot of thrust and orogen, and over the old North African subduction zone toward the India and the Himalaya. And so I will show an example from USA, an example from India, and interest in North Africa. And as you can see here, highly structured domains in North Africa, Tunisia, Algeria, and Morocco, due to the subduction and the movement in between Africa and Eurasia during the last Miocene compressional event and still continue now. The idea is, the old classic things is to look for anticlines and structures on anticlines and to look for reservoirs. But we might have some petroleum trapped beneath the thrust in the foot wall of reverse fault, which may constitute a very nice object for exploration. The first example is from Utah, the Jurassic limestones, and the pin view. And as you see here, this nice oil field is beneath the thrust belt system with a column of oil for about 200 feet or more. And it's a very interesting thing. One more. The Assam Arakan thrust belt in India. And you can see here the Naga thrust. And those are fields in foot wall structures. As by seismic lines, you can see the foot wall anticline beneath the thrust. In Tunisia, we have the Khsham al-Artsuma structure. It's a structure located to the east of north-south axis, mapped in 2012. And this map shows the Triassic. It's a faulted anticline with a Triassic deposit, Triassic sediment injected along faults. The cross section shows these structures with a high inverted northern flank of the structures and verticalized to reversed southern flank. And you can see here the Autorevian sediments in contact directly with the Miocene sediments. It's a big thrust, reverse fault or thrust. The model here, the tip domain structural model created by this study, shown a fault propagation fault models in reference to Maclay in 1992 for Khsham al-Artsuma. And as you can see here, beneath, we might find some layers in contact directly with this reverse fault and some Triassic injected along this fault system. So Khsham al-Artsuma structures lying with the southern part of the Irrigab pool, and in Irrigab pool we have a very nice deep and these seismic based cross sections along Ali ibn Khalifa Irrigab pool. We can see that the main target, which is Jurassic, that is proven hydrocarbon bearing in Sha'al area, as previously mentioned by my Professor Mohammed Susi this morning. The system exists. The modeling in Ali ibn Khalifa gave a very nice mature source rock, and we might have some expelled hydrocarbon up deep toward the southern part of Ali ibn Khalifa. So, like that, we might find some trap beneath these structures within the Jurassic. In addition to this, the Jurassic, the net to gross, it's very high. We have a 600 meters thick of Jurassic. So the potentiality is very good. Toward the Ktifa, Qarwan Basin, Ktifa structures, we will see a correlation from northwest to southeast, north-northwest to south-southeast, and two seismic lines, L1 It passes along through the Ktifa 1 well, Ktifa 2 well, Qarwan well, Zas, and the last one is BBZ well. And the well L2, a little bit to the east in this domain. As you can see here, this domain, the major outcrops in this eastern part are Miocene to Quaternary outcrops. So all the series are overburdened and underneath within the subcrop. So the correlation here, well correlation, especially Ktifa well, we crossed all the section toward the option, and after we cross one more time the companion restriction abiode formation, which represent a main target in the area, and this is represent the main reservoir in Sidi Kilani oil field, the famous Sidi Kilani oil field, the only one oil field in this Qarwan basin. Regional cross-section, seismic sections. It's a little bit parallel to the same correlation to show this structural form. So an interpretation, and you can see over there this big Ktifa fault system, which is reverse or thrust fault in Qarwan. And this, it might be the footwall. This is the footwall of this big fault. Okay? Probably this fault, it was controlling the sedimentation during the early Cretaceous and upper Cretaceous and Tertiary, and invert during the last compression event as marked by the Messinian unconformity to the top. And the Messinian unconformity itself, it's folded. That means that the last compression of the post-Villafranchian or quaternary, the early quaternary compression exists one more time. And we can see that in the folded Villafranchian series in Sahel domain. So, in this well, Ktifa 2, it tested 1,000 cubic meters of gas from the abiode formation. We penetrated just a little bit of the perimeter, a few 10 meters of the abiode formation. And we tested 1,000 cubic meters of gas. Probably the system here, the green one, is the well-known Fahdan formations, the main source rock in the area. And as you can see, at 3 or more than 3 in two-way time, it's good to be mature and expel its oil. One more, section L2, abnormal thickening. Thinking about the detachment level within the Alag shales, and the interpretation show that this detachment level is within Alag, and the anti-Alag series, such as the Fahdan formation and the Serge formation, which represent itself, one more time, a good target in the area. The first one is the abiode, the second one is Serge formation, which is a limestone and platform, and here you might find some reefs, probably downlapping toward the basin here. Underneath this fault and this detachment level and detachment fault, we might find some oil, probably the source might be mature toward the north, and the migration up deep toward the platform. By down-thrown migration and lateral migration from the Fahdan formation toward the Serge reservoirs. And here, one more time, I can talk about probable reefs and shoals. And I know that there is reefs and shoal in absent, in outcrops, not so far from this area. Okay, and might represent very nice stratigraphic traps which are potential for exploration. Just a small model, the trapping model and migration system. I think that all the oil during rifting, it migrates toward the up deep, toward the footwall of normal faults. And this oil, in one more time, still beneath in the footwall. When we invert the overburden systems, it will be in the 4 deep, in the front of this thrust and reverse faults, and might represent, one more time, material source rock here, like Qarwan Basin, I presented that, and by the overburden of the post-folding and post-thrusting event. And we might migrate the probably initially oil or a secondary oil that comes from this source rocks will be material in post-tectonic event. For northern Tunisia, just a quick look, our structural cross-section by Al-Ushi oil in 2004. It's highly structured, a lot of Triassic detachment levels, and we have the thrust belt over here, and the autochthonous to para-autochthonous unit underneath, and might present some traps and some structures below. Those are structured within Jurassic and companion maastrichtian limestones. It's a very nice fractured reservoir, which is proven in Tunisia and potential. This for offshore, one more time, the example from Italy, 6 billion barrels of oil in place in the Apulian platform carbonates beneath the thrust belt system. Okay? For both interpretation of Anadarko, we might see that we have probably some structure beneath the Numidian flesh thrusted along the north offshore Tunisia. That might be an object for exploration. We need more money to explore this, but if we make a discovery, it will be very nice, and we will earn a lot of money too. So in conclusion, Tunisia is a highly structured country. In fact, exploration needs multidisciplinary data to be more reliable. Traps related to footwall faulted faults and thrusts are abundant and needs to be ranked and tested as a new horizon for exploration. The key exploration for the northern thrust belt is to drill a real wildcat, and any discovery can make the area very exciting. And thank you.
Okay, thank you, Mr. Ferris. We have a few minutes for a question if there is any.
Mohamed Darab from Sonatrak. First, if you come back to the Chained-1 section where you displays the inversion. Where you mentioned the Ktifa structure with the recent inversion.
Yes.
With some depositional faulting.
This one.
Yeah? Yeah. Yes.
Yes.
In the right side of the section, maybe you did the work, so we need more time to interpret, and
yes,
maybe I see that the reverse fault do you think it isn't recent? It is maybe Miocene, no? The reverse fault. I think maybe there is an inversion after a normal faulting during lower Cretaceous, no?
Yes. Yes. There is a
Because
normal
it's
faulting.
the-
It's uninverted.
There is some thickening in the one side of, for example, Maastrichtian Paleocene. There is a thickening beside the fault. Maybe the thick
Yes.
section of Maastrichtian Paleocene was a foot wall
That's the Maastrichtian.
in a certain
Green.
time, yes.
Yes.
And the reverse fault is maybe Miocene, no?
It might be Miocene. Yeah.
So, and this fault controls maybe the depositional fault maybe was rather normal faults in a
Yes,
certain time.
Yes. Yes.
And there was an inversion.
Yes,
Okay.
an inversion, yeah. Inverted
thank you.
structures, an inversion, and the
In
thrusting.
the recent time. Okay,
Yeah.
thank you.
Yeah, I think this is a good remark because I think what you are calling here as a thrust fault in Pelagian block is more linked to the
Reverse
circular
fault,
inversion
reverse.
and reverse fault more than it looks like flower structure more than it's like inverted structure more than nomenclature maybe should be changed for this Pelagian blocks more than thrust faults, if I can say, which needs displacement and the known displacement.
Yes, it depends on this
Yeah.
displacement.
Yeah.
Because we have here a detachment level within Triassic. If you have a long way displacement, we might talk about the thrusting. If the displacement is not so important, we'll talk about inversion and reverse
And
fault
reverse fault.
simply.
And I
Don't-
agree for the northern part of Tunisia that there are a lot of identified structure beneath the Numidian sheet, but which maybe at the moment needs good imaging, seismic imaging to better identify this kind of structure.
Yes,
Yeah.
yes.
Any other?
Yeah.
Yeah, we have already this kind of data, I think, in Tunisia. It's only, yeah, yeah. Okay, any other question? Thank you, Sefez.
Thank you.
So we'll move to the second. Yeah.
In the log. I put the log before, just in correlation.
The discretation is series repetition, yeah.
At first, I start by this correlation. And this correlation, I put the log, and you have the option, and the Triassic, and you
How to
counter one more time to combine Maastricht limestones. And we test from this small part below and near to the total depth of this well. We tested some gas.
Okay, thanks, Sefers.
Thank you.
So we'll move to the next presentation. I don't know if Mr. Nouri Muhammad Fellow is here or not. I don't think so. Mr. Payet Matthew. Okay, so we'll be back in 15 minutes for the third presentation, as the second presentation will not be done, and due to the absence of Mr. Nui. So we'll be back in 15 minutes.